Hi there, welcome to video 17, which is a tutorial on non-right angle triangle trigonometry. I would have expected you'd have done videos 15 and 16 on right angle trigonometry, and now we're moving towards the grade A and A star material in unit 3. I'm going to introduce to you what's called the sine rule and the cosine rule for triangles without 90 degrees in them. We're going to do some examples and then you're going to move on to video 18 and practice the past paper questions. Okay, let's start straight away with the sine rule. Okay, now the sine rule works for any triangle. So if you see a triangle without a 90 degree in particular, you can think to yourself, is the sine rule working here? Or later, the cosine rule. So remember, for Pythagoras and normal trigonometry, SOHCAHTOA, you needed 90 degrees. For sine rule, it works for any triangle. So that is any triangle, it doesn't even have to have a 90 degrees. Now, it's important how we label our triangles. This works with the sine and cosine rule. We always use capitals for angles, and we always use lowercase for sides. So say in a particular triangle here, I've got capital angle capital A, angle capital B, angle capital C. I call the side opposite capital A little a, and I call the side opposite capital B little b, and I call the side opposite capital C little c. Okay, now what the sine rule says, it says that if I want to work out sides, the following rule is helpful, and here's the rule. If you take this side and divide it by sine of this angle, you get the same answer as if you do this side divided by sine of that angle, and the same answer as if you do this side divided by the sine of that angle. And you can use this to help you find missing sides. I'll show you how in a second. If you want to find angles, the same rule applies, but you just flip the fraction. So instead of the little a, the side on top, you make the angles or the sine of the angles on top. So sine of capital A over little a is always equal to sine of capital B over little b is always equal to sine of capital C over little c. And this rule is given to you in the formula book. Okay, and you just need to remember that is going to help you work out missing sides, and you just need to think, for missing angles, flip the whole thing. The last thing to say before we move on to the sine rule, you always use the sine rule if they give you an angle, say they told you that is 40, and they give you the side opposite, say they told you that was 10 meters. If ever you see a given angle and a given side opposite in a non-right angle triangle, you use the sine rule. That's how you know to use it. Okay, let's go straight on and do a question. Here's the first question. None of these triangles are drawn to scale or drawn to look exactly precise, by the way. Now, let's go through all our potential options to find this missing side x to 1dp. Now, can we use Pythagoras? No, it's not a right angle triangle. Can we use SOHCAHTOA? No, it's not a right angle triangle. So it's the sine rule or the cosine rule. Now, because we've been given an angle and a side opposite, we know we must use the sine rule. Okay? And we turn to the front of our formula booklet and it says this. Always label the side you're trying to find little a. That makes that big A. And then the other two, well, they're just B. Forget about C. We don't have a third angle and side here. So call that big B and call that little b. Okay, so we know that A over sine A equals B over sine B. So let's substitute in. X over sine of the angle opposite, sine of 60, must therefore equal, okay, 10, this side, divided by sine of 40. Now, I want to find x, so I multiply both sides by sine 60, and the result of that is the sine 60 ends up on the top of this fraction here. Okay, like that. And all we have to do is type that into the calculator and we have our x and round appropriately. So in our calculator we type 10 sine 60, usually better to press equals at that stage, and then divided by sine 40 equals. And you should get 13.5 centimetres. Have a sense check, does it look right? That looks like it could be about 13.5, yes. So the key to this is for non-right angle triangles, if you've got an angle and a side given that are opposites, you use the sine rule. Label the side you're trying to find little a, and then the angle opposite that, big A, and the other two, little b and big B. Substitute into the formula and rearrange to get your unknown. Okay, why don't you have a go at an example? I'm going to stop talking for 10 seconds, you pause, have a go, and check you got the right answer. And the answer to this question then to one decimal place was as follows. So when I worked it out, I got 22.6 centimetres. Okay, let's try another question. Here we go. This time I'm going to use the sine rule to find an angle, not a side. Now let's think of all the options available to us. Can we use Pythagoras? Well, no, it's not a right angle triangle and that doesn't find angles anyway. Could we use trigonometry, SOHCAHTOA I mean? Well no, this is not a right angle triangle, doesn't look like it, so no. So it's the sine rule or the cosine rule. Now because we have that length and that angle given and they are opposite, we know for a fact we should use the sine rule. Okay, so we're going to use the sine rule. Now label the angle you're trying to find capital A. Then the side opposite is little a, and then the other two, well, this angle must be capital B and this must be little b. Okay, substituting in, we just care about this part really. This is in the formula booklet. We would therefore say that sine of the angle, okay, divided by 10 must equal sine of this angle, sine 60, divided by 20. Okay, we want to find the angle, so let's first of all multiply by 10 to remove this divide by 10 here. So sine of the angle, if we multiply both sides by 10, I would get 10 sine 60 divided by 20. Okay, and tap that in the calculator, that would give me 10 sine 60 equals divided by 20, you would get 0.433. Now careful here, there's one extra step here. That is sine of the angle. To get the angle, you inverse sine that number you just found. So you inverse sine 0.433. Advanced users on the calculator would inverse sine the answer that your calculator has just worked out. So if you do that, you should get an angle of 25.7 degrees. 25.7 degrees. Okay, so just like before, we're using the sine rule, but we are using the flipped version of the sine rule. This particular one actually wasn't given in the formula booklet, but because you're finding an angle, you flip the one in the formula booklet and use that. You rearrange to get sine theta. To get theta, you work out the inverse sine of that number. Okay, have a go at a question yourself, and in 10 seconds I'll go through the answer. And the answer to this question I got is as follows. I got 10.8 degrees, okay, and it was a simple application of the formula I've shown you. Okay, so that's the sine rule for working out sides and angles. Remember, with the sine rule, you use it if ever you've got a non-right angle triangle and you are given an angle and the opposite side. That tells you to use the sine rule. Okay, let's move on to the cosine rule. Here are the two versions of the cosine rule. The cosine rule is for similar triangles, okay, labelled up the same way. If you've got a capital angle A here, that's little a side. Capital angle B here, little b side. Capital angle C here, little c side. Now there are two versions of the cosine rule. One of the versions of the cosine rule is helping you find a side. In order to do that, you need to know two of the sides. let's say you know sides B and C, okay, and you know the angle in between. You need to know the two sides and the angle in between. That helps you work out this missing side, okay? That's that first version. The second version is if you are happen to be told all three sides. If you are told all three sides, okay, then you can work out any of the angles. You can work any of the angles if you know three sides, and here are the formulas for them. Okay, now this formula is given to you in the formula booklet, this is not. Okay, so firstly, just before we move on to using these, I want to show you how to get from one formula to the other. Now, this is given in the formula booklet to find a side, okay? So all you've got to do is be able to label your triangle correctly and substitute in, and you'll get the answer to the cosine rule each time. This is not in the formula booklet, how to find an angle, okay? Now this equation here is just that equation or formula rearranged. So I need to show you how to get from here to here so you can remember. So let's look at the formula we're given in the formula booklet. Here it is, okay? How do we get, this is, remember, if you want to work out a side, and this is for working out an angle. So how do you get from one to the other? Well, really, this is a rearrangement of that. Now, those confident with algebra, that's a very easy operation. For those who are coming from the foundation side of things, this might be quite hard. So I'll just show you a way to remember it. Effectively, the a squared and the 2bc cos a get swapped. Okay, these get swapped like that, right? So going back here, that was over here before. I've just swapped them round, keeping everything else the same. Okay, and then I just take the 2bc and I divide both sides by 2bc to get this formula here. So let's go back to the original to see how I could possibly get that on my own. I start off there in the formula booklet, okay? I want to make cos A the subject of the formula. So really what I do is I take the 2bc cos A that side and take the a squared that side and keep the b squared plus c squared there. And then I divide both sides by the 2bc and I get my formula, okay? And here is the formula that's not in the formula booklet, but now I hopefully can get. Okay, anyway, let's go on to applying these formulas, and I want to show you the easy way of doing that. So far we just know formulas, we have no idea how to use them. Here we go. Here's a question. It says find this here. Now, go through the usual protocol. Could it be Pythagoras? No, it's not a right angled triangle. Could it be SOHCAHTOA? No, it's not a right angled triangle. Could it be the sine rule? No, because you're not given an angle and the side opposite. It must be, by default, the cosine rule. It has to be. Now, you always label the side you're trying to find little a. I don't care if they call it X, Y, Z, B, Jim, or whatever, you call it little a. And that helps you label the rest of your triangle. The angle opposite is therefore big A. And the two other sides, well, it doesn't matter what you can call them. That could be B, that could be C, or the other way around. It doesn't matter. And you substitute into the formula given in the formula booklet. So, A squared must equal B squared plus C squared, so 17 squared plus 12 squared, okay, minus 2 times B, which is 17, times C, which is 12, and times cos of the angle 47, okay? And if you work all that out, it gives you A squared. So on your calculator, practice getting the right answer as I'm getting here. So 17 squared plus 12 squared minus 2 times 17 times 12 times cos 47. And with a bit of luck, you should get 154.74 odd. But that's A squared. They want you to find the length, so you square root it. So A is the square root of the answer button in your calculator, or the square root of 154.74, and you should get 12.44 centimeters. Does it look reasonable? Yeah, it looks pretty reasonable. And there you go, simple as that. So decide what rule you're using, label the side you're trying to find little a, the other two b and c in any order, and substitute into the cosine rule and square root, and you get your answer. Okay, I'd like you to have a go at one yourself. Have a look at the next slide, pause the video, have a go, and in 10 seconds I'll go through. And here's the answer to this question. Take a look, and I got 16.90 centimeters. Okay, last one here. We'll do one more example. We're using the cosine rule to find an angle. So let's take a look at the question. Here we're finding an angle here to one decimal place. Let's go through the usual protocol. Could it be Pythagoras? No, it's not a right angle triangle, and we're finding an angle anyway, so no. Could it be SOHCAHTOA? No, it's not a right angle triangle. Could it be the sine rule? No, we don't have an angle and the side opposite, so no. It must be the cosine rule. Now remember, in your formula booklet, this will be written as the cosine rule. A squared is b squared plus c squared minus 2bc cos of a. You've got to rearrange that so you bring so that you get cos a is b squared plus c squared minus a squared, all divided by 2bc. You must be able to get that yourself. Now, right, it's all very well then having rearranged that formula. How do you use it? Well, always, always, always call the angle you're trying to find capital A. Don't care whether they call it B, C, Jim, whatever, you call it capital A. And that makes the side opposite little a. The other two call B and C any way you want. It doesn't matter the order. That could be B, that could be C, or the way I've got it. And then substitute into this formula. So cos of the angle you're trying to find, theta, must be b squared plus c squared, so 10 squared plus 17 squared, okay, minus a squared, so minus 15 squared, divided by 2 times b times c, so 2 times 10 times 17. Okay, so on your calculator, the way to do this is do 10 squared plus 17 squared minus 15 squared, and then press equals to get what that is. That would give you, say, 164 if you did that, divided by 2 times 10 times 17, okay, which I think on the bottom would give you 340. But when you work that out as a decimal, you get 0.482, etc. But that's cos of the angle. You don't want cos of the angle, you want the angle. So to get cos of the angle, you apply inverse cos to 0.482, or aunts, if you're familiar with your calculator. So you inverse cos that number and you get 61.2 degrees. And you're done. You have answered an A-star question there. Okay, at the end here, I want you to have a go at an example finding an angle yourself and check you can get the right answer afterwards with my working. Off you go. And here's the answer I got to that last question there. I got 86.1 degrees. Okay, so we finished there, all the non-right angle trig. Let's remember what they were. It was the sine rule to find sides, the sine rule to find angles, the cos rule, cosine rule to find sides, and the cosine rule to find angles. Okay? And it was applying the various formulas and how you label them. So just to say again how to do it, if ever you see an angle and the side opposite, you use the sine rule. If you don't see that and it's a non-right angle triangle, you're thinking the cosine rule. The cosine rule usually comes into play if you have two sides and the angle in between, or if you have three sides. And that's all I have to say on non-right angle trigonometry. I hope you found the following video useful. I'd move straight away to the next tutorial, which should be video 17 on the video 18 even on the exam questions that have come up on this topic. Thanks for watching.